Hello friends, time to practice arithmetic progression. It's chapter 5 in class 10 syllabus. As always, we will summarize the key concepts first and then solve questions from previous year board exam papers. Before we proceed, if you're yet to subscribe to the channel, kindly subscribe and check the playlist. You will find videos to practice all the chapters in class 10 max. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number d to the preceding term, except for the first term. Example 2, 4, 6, 8, so on till 20. In this list, we see that the first term is 2. Generally, the first term is denoted by the alphabet A, so A is 2. And the difference between any two successive numbers 6 minus 4 is 2, 12 minus 10 is 2, 18 minus 16 2. So the difference between any two successive numbers is called common difference, and that is again 2 for this arithmetic progression. The fixed number d is called the common difference. It can be positive, negative or 0. So when the common difference is negative, the progression will be decreasing, like 15, 10, 5, 0, minus 5, minus 10. You can see here that I'm taking away 5 from each term to get the next term. So the common difference d will be minus 5 in this arithmetic progression. The general form of an arithmetic progression is A plus D, A plus 2D, A plus 3D, and so on. So A is the first term and we add D to get the next term. One more D is added to get the next term and so on. If there are finite terms in an arithmetic progression, then it is called finite AP. There is a last term in finite AP. The last term is generally denoted as L. L for last. If there are infinite terms in an AP, then it is called infinite arithmetic progression, and there is no last term in an infinite arithmetic progression. There are few important formulas that you have to remember. The nth term of an arithmetic progression is given by A of n, that is how we denote the nth term, is equal to A plus n minus 1 into D. A is the first term, n is the number or the position of the term which you need to find, D is the common difference. Suppose we want the fifth term, then it is denoted as A of 5 is equal to A plus 5 minus 1 is 4 into D. The sum of the first n terms of an AP is given by S is equal to n by 2 into 2a plus n minus 1 into D. If L is the last term of the finite AP, say the nth term, then the sum of all terms of the AP is given by S is equal to n by 2 into A plus L, where A is the first term, L is the last term. So this is in case of a finite arithmetic progression. Now there is an important note. Sum of first n natural numbers is n into n plus 1 by 2. So natural numbers start from 1, it goes on 2, 3, 4, 5 and so on. So it's an infinite list. We see that the first term A is 1 and the difference between the successive terms, that is common difference, is 1. This is in case of natural numbers. Now if we want to find the sum of first n natural numbers, let's apply this formula. S of n is equal to n by 2 into 2. A is 1 in case of natural numbers, plus n minus 1 into d is again 1 in case of natural numbers. So n by 2 into 2 minus 1 is 1. So n plus 1. So that is how we arrive at this formula. The sum of first n natural numbers is n into n plus 1 by 2. So these are the key formulae based on which the questions can be solved. So let's begin solving the questions from previous year board exam papers. Question number 1. Find the number of terms in the arithmetic progression 18, 15 and a half, 13, so on till negative 47. It's a 1 mark question from 2019. So here the first term in the progression is 18. So A is 18. Difference between the successive terms we need to find out. It is 15 and a half minus 18, which will be minus 2.5, or in fractional form it is minus 5 by 2. Now we need to find the number of terms in this progression. Minus 47 is the last term. We know that the nth term is written as a plus n minus 1 into d. Minus 47 is the last term. A is 18. N we need to find, and the common difference is minus 5 by 2. So if we solve this equation, we can find the value of n. So we get n as 27. So the number of terms in this progression is 27. Question number 2. How many multiples of 4 lie between 10 and 205? It's a 2 mark question from 2019. So after 10, the first multiple of 4 will be 12, followed by 16, then 20, 24, so on. What will be the last term? 204 will be the last term of this series. It's a multiple of 4 and just under 205. The first term A is 12. The common difference is 4. It's multiples of 4. N we need to find. Again, the last term is 204. The nth term is given as A plus n minus 1 into D. So 204 will be A, which is 12, plus n minus 1 into D is 4. So n is 49. There are 49 multiples of 4 between 10 and 205. Question number 3. Determine the AP whose third term is 16 and seventh term exceeds the fifth term by 12. 2 mark question from 2019. So the third term is 16. A of 3 is 16. Seventh term exceeds fifth term by 12. A of 7 minus A of 5 is equal to 12. Now, if this is a part of the arithmetic progression, we have fourth, fifth, sixth, and seventh term here. We know that the difference between fifth and sixth term is D. Again, between sixth and seventh term, it is D. Because between any two successive terms, it is D. It's given that the difference between the seventh and the fifth term is 12. So it will be 2D. So twice the common difference is 12. Hence the difference is 6. So we know that A of 3 is A plus 3 minus 1 into D, because A of n is a plus n minus 1 into d. So we can substitute a of 3 is given as 16. The first term a we do not know. 2 into 6. So 16 is a plus 12. A will be 4. So we know the first term of the arithmetic progression. We know the common difference. So the AP will be starts with 4 plus common difference is 6. So 4 plus 6 will be 10. Again add another 6, 16, 22, so on. Question number 4. Which term of the arithmetic progression 3, 15, 27, 39, so on will be 120 more than its 21st term? 2-mark question from 2019 board exam. So let's first try finding what the 21st term is. A21 will be a plus n minus 1 into d. So n is 21 and the first term in the progression a is 3. Difference between the successive terms is 12. So let's substitute them. A of 21 will be 3 plus 21 minus 120 into d is 12. 243 is the 21st term. 120 more than 21st term. 120 plus a of 21 will be. So in this arithmetic progression, for what value of n will a of n be 363? A of n is generally written as a plus n minus 1 into d. 363 is the term that we need. 372 by 12 will be 31. So the 31st term will be 120 more than its 21st term. Fifth question, if S of n, the sum of first n terms of an AP is given by S of n is equal to 3n square minus 4n, find the nth term. It's a 2-mark question from 2019 board exam. A of n is equal to a plus n minus 1 into d. We've been asked to find the nth term. S of n is given in terms of n. So similarly, the nth term also we need to find an expression in terms of n. So we need to find out what is a, the first term, and what is d, the difference. For that, we will make use of this expression here. It is given that the sum of first n terms is 3n square minus 4n. Now for the first term, that is when n is equal to 1, the sum of the first term is equal to the first term itself. Okay, the arithmetic progression will be A1, A2, A3, A4, so on. When n is 1, the sum of the first term is equal to the first term itself. So we can equate S of 1 is equal to A of 1. S of 1 is equal to 3 minus 4, substituting n as 1 here. So it is minus 1, which is same as a of 1 or a, the first term. So the first term is minus 1. Now let's consider when n is equal to 2. S of 2 is 3 into 2 square minus 4 into 2. 12 minus 8, which is 4. So S of 2 is 4. Sum of the first two terms minus sum of the first term will give you the second term. So A2 will be S2, which is 4 minus minus 1, which is 5. Second term is 5. So difference D is A2 minus A1, which is 5 minus 1, 6. A of n is A plus n minus 1 into D. We found out the first term as minus 1 plus n minus 1 into the difference is 6. So we can write A of n as minus 1 plus 6n minus 6. So A of n will be 6n minus 7. So we have got an expression for the nth term in terms of n. Sixth question. Which term of the arithmetic progression minus 7, minus 12, minus 17, so on will be minus 82? Is minus 100 any term of the AP? Give your reason. This is a 4-mark question from 2019 board paper. In this arithmetic progression, the first term A is minus 7. The common difference between the two successive terms is minus 5. A of n, the nth term is given as A plus n minus 1 into D. So for what value of n will A of n be minus 82? Let's substitute A of n is minus 82. Minus 7 is the first term. N is 16. So the 16th term will be minus 82. Now we need to find if minus 100 is any term of the given arithmetic progression. Let's assume that minus 100 is a term. So let minus 100 be the nth term of this arithmetic progression. So minus 100 will be A plus n minus 1 into D for some value of n. Again, A is minus 7. Now, n is the position of a particular term. So it has to be a positive integer. Here we can see that n's value is 98 by 5, which is not an integer. So we can conclude that our assumption that minus 100 is the nth term is wrong. Question number 7. How many terms of the arithmetic progression 45, 39, 33 must be taken so that their sum is 180? Explain the double answer. It's a 4-mark question from 2019. We know that the sum of the first n terms is given by S of n, which is equal to n by 2 into 2a plus n minus 1 into d. For this progression, the first term a is 45. The difference d is minus 6. 39 minus 45 will be minus 6. And the sum of the first n terms is 180. So for what value of n will S of n be 180? Let's substitute the values in this equation. Let's divide this entire equation by 6. Now we have a quadratic equation in terms of n. We can split minus 16n to be minus 10n minus 6n. So n square minus 10n minus 6n plus 60 equal to 0. This implies n can be 10 or n can be 6. S of 6 will be equal to S of 10, which is equal to 180. Sum of the first 6 terms is equal to sum of the first 10 terms, both equal to 180. This shows that the sum of the terms between the 7th and the 10th position is 0. Since the difference is in negative minus 6, sum of the terms between the 7th and the 10th position will be negative, and the positive and the negative integers terms will cancel out each other. So the sum of the terms between the 7th and the 10th position is 0. That is why we get two values for n as answer. Question number 8. If the sum of the first p terms of an arithmetic progression is q and the sum of the first q terms is p, then show that the sum of the first p plus q terms is minus of p plus q. 4-mark question from 2019. The first statement tells that sum of the first p terms of the AP is q. So sum of the first p terms is q. Sum of the first p terms is given by p by 2 into 2a plus p minus 1 into d, which is equal to q. So we have 2a plus p minus 1 into d is equal to 2q by p. Similarly, the sum of the first q terms is p. So S of q is equal to p. S of q, sum of the first q terms is written as q by 2 into 2a plus q minus 1 into t, which is equal to p. So we have an equation 2a plus q minus 1 into d will be equal to 2p by q. Let this be equation number 1 and this one be equation number 2. We have two equations in terms of variables a, d. We can solve these two to find the value of a or d. Let's subtract first and the second equation. 2a minus 2a gets cancelled. So we'll have p minus 1 into d minus q minus 1 into d is equal to 2q by p minus 2p by q. So d is minus 2 times p plus q by pq. We will be later using this value of d. We need to find what is the sum of first p plus q terms. So S of p plus q will be p plus q by 2 into 2a plus p plus q minus 1 into d. So let's simplify this. I'm pulling out the q outside the bracket. As per the first equation, 2a plus p minus 1 into d is 2q by p. So let's substitute 2a plus p minus 1 into d as 2q by p plus q into d. For d, we have already found out an expression minus 2 times p plus q divided by pq. Let's substitute that expression. Minus 2 times p plus q divided by pq. So here q and q gets cancelled. So we are left with minus of p plus q. Hence we have proved that sum of the first p plus q terms is equal to minus p plus q. Question number 9. If m times the mth term of an arithmetic progression is equal to n times its nth term and m is not equal to n, show that m plus nth term of the arithmetic progression is 0. It's a 4-mark question from 2019 board exam. M times the mth term. So m into a of m is equal to n times the nth term, n into a of n, where m and n are not equal to each other. So we can expand the mth term as a plus m minus 1 into d. Similarly, n into nth term is generally written as n minus 1 into d. We will expand and rearrange the terms. M square minus n square, I am writing it as m minus n into m plus n. I am taking a negative 1 as common, so it will be m minus n into d. Let's divide the entire expression by m minus n. So you will have a plus m plus n minus 1 into d is equal to 0. So the expression that we are having is a plus m plus n minus 1 into d is equal to 0. General form of nth term is a of n is equal to a plus n minus 1 into d. By comparing these two, we can say that a plus m plus n minus 1 into d is nothing but a of m plus n, which is the m plus nth term. Question number 10. The sum of the first three numbers in an arithmetic progression is 18. If the product of the first and the third term is 5 times the common difference, find the three numbers. It's a 4-mark question from 2019 board exam. Let the arithmetic progression be a plus d, a plus 2d, so on. So a is the first term and d is the common difference. It is given that sum of the first three numbers is 18. S of 3 is 18. So it is nothing but a plus d plus a plus 2d is equal to 18, which is 3a plus 3d is equal to 18, or a plus d is equal to 6. We can express the common difference d as 6 minus a. Now another condition given is if the product of the first and the third term is 5 times the common difference. So a1 into a3 is equal to 5 times the common difference d. a1 is the first term, which is a, into third term is a plus 2d is equal to 5d. A into a plus 2 into d is 6 minus a, so substituting the value for d, again d is 6 minus a. So we have a quadratic equation in terms of a square minus 17a plus 30 equal to 0. Now this can be factorized as a minus 15 into a minus 2. So a can be either 15 or a can be 2. When a is 15, common difference will be 6 minus a. So it is minus 9. And the three terms will be 15, 6 and minus 3. When a is 2, common difference will be 6 minus 2, which is 4. And the first three terms will be 2, 6 and 10. So we have two possible solutions. When a is 15, the terms are 15, 6 and minus 3. And when a is 2, the first three terms will be 2, 6 and 10. Question number 11. The ratio of the sums of the first m and n terms of an AP is m square is to n square. Show that the ratio of its mth and nth terms is 2m minus 1 is to 2n minus 1. It's a 4-mark question from 2017. Sum of first m terms by sum of first n terms is equal to m square by n square. Now sum of the first m terms is written as m by 2 into 2a plus m minus 1 into d. Sum of the first n terms is n by 2 into 2a plus n minus 1 into d. It is equal to m square by n square. Now we can simplify this. So we will have 2a plus m minus 1 into d by 2a plus n minus 1 into d is equal to m by n. We will cross multiply and simplify this expression further. We have m minus n into 2a minus d is equal to 0. M and n are not equal to each other, which implies 2a minus d is equal to 0. So the difference d is equal to 2a. We have asked to prove that ratio of the mth and nth term is 2m minus 1 is to 2n minus 1. So am by an will be, am can be written as a plus m minus 1 into d. And nth term is a plus n minus 1 into d. Let us substitute d as 2a here. 2m minus 1 and 2n minus 1. So the ratio of mth term to the nth term is 2m minus 1 divided by 2n minus 1. Question number 12. Ramkali required rupees 2500 after 12 weeks to send her daughter to school. She saved rupees 100 in the first week and increased her weekly saving by rupees 20 every week. Find whether will she be able to send her daughter to school after 12 weeks. What value is generated in the above situation? It's a 4-mark question from 2015. So the mother saves rupees 100 in the first week. Next week she increases it by 20 rupees. So the amount saved is 120. Again next week plus 20 more rupees. So it will be 140, 160, so on. So if she saves in this pattern, will she get rupees 2500 after 12 weeks to pay her daughter's school fees? That is the question. So if n is equal to 12, will sum of the first 12 terms will be equal to 2500? That we need to find out. The first term is 100 and the common difference is 20. Sum of first n terms is n by 2 into 2a plus n minus 1 into t. So when n is 12, so sum of the first 12 numbers or 12 terms is 2520 rupees. So the mother will have rupees 2520 after the 12 weeks. So the conclusion is she will be able to send her daughter to school after 12 weeks. What value is generated in the above situation? It just shows that even saving small amount regularly will be of big help. So those are the 12 sums that I wanted to solve. Now there are few more sums for your self practice. Please take a screenshot. The answers are also given below the questions. You can verify your answers. So that's the end of this video, my friends. Thanks for watching. Hope it was useful for your exam preparation. To practice other chapters, kindly subscribe to the channel and check the playlist. Do not forget to like, comment, and share the videos with your friends. Keep practicing. I'll meet you soon with another learning video.